Okay, so we know that z is equal to x plus iy and z mod is x squared plus y squared square root, right? Now, if you want to plot this one, so we are talking about the z, right? We are talking about the z. Now, z is x plus iy, so that can be any point on this plane, right? Now, z mod means the radius, right? So any point on the space, but restricted by a radius, right? So z can be here, 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 z can be here. So that looks like this. That looks like this, where z can be anywhere. I would say z is here, which is xy coordinate. Actually, this xy coordinate can be here. If that happens, this is the radius, right? So this is so arbitrary because x and y can be any point, right? But if you pick this point, radius is this. Because this distance from here to here is z mod, right? Now, let's think about this. So consider z mod d is equal to 1 and z mod d is equal to 2. Consider these two. So we understand z is x plus iy. Mod is equal to 1, that's what it says. X plus iy mod d is equal to 2, right? So mod d is nothing but x squared plus y squared square root, right? Square root is 1. So from here, x squared plus y squared square root is 2. Now from here you get x squared plus y squared is equal to 1 when you square it, and from here you get x squared plus y squared is equal to 4, right? Now what is the idea here? Idea is this. Idea is you get a circle like this, and you get another circle like that. Now, the radius from here to here is going to be 1. The radius from here to here is going to be 2. So now this will tell you, according to the first picture, z is on this. Z is on this circle, right? According to the second one, because radius is 1, now there is a radius restriction. Now here you didn't have a restriction. You could go any number of circles like this because there is no restriction in this way. So now we impose the restriction in this way. See, this is a specific thing. So here, anywhere, right? So that is z, according to that question, second situation. Got it? So now this is our space boundary, right? So we impose the radius so that we restrict the radius to be this. Okay, so all the z values should be on that circle. So now, if you think about that, how many z values you are expecting? So we understand z mod is equal to 2, right? Now in here, z is x plus iy, right? So we expect infinite number of z values, right, on this circle. On this circle with radius 2. Got it, right? Okay. Now we will do another restriction. That restriction, I will go to the next page. That restriction is this. Let z mod d is equal to 2, and I would say arg of z, right? Arg of z less than pi divided by 3, greater than pi divided by 6. Now you understand, if you read this carefully, this is your radius restriction. This is your angle restriction, right? So now if you want to draw this one, this is very easy. So you are going to draw that. So your radius is going to be 2 in this case. Now that restriction is there, so that means you are expecting all your z values on this circle, right, according to this one. Now we will impose this one. So if you impose this one, this is angle, right, theta, between this. So we will do that here. So pi divided by 6 is this, right? Pi divided by 3 is this, right? So now this will tell you it should be between these two. So now you can see, if you want to impose both of these conditions, you must take, right? You must take this. You must take this. So this will tell you this so-called z under this restriction should be here, 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 and here only, right? Yeah. So that's the idea. Oh, good. Now, next one. Okay. Let's think about consider z bar is equal to 1 and z minus 2 bar is equal to 1. Now, if you really understood this one, this is going to be x squared plus y squared 1. If you really understood this guy, this is going to be x minus 2 squared plus y squared is equal to 1. Right? So now, what we are going to do, knowing this, straight away, we can think about this. Now we will draw this one, okay? We will draw this one. If you draw that, so I'm going to do the first one. First one is like this. It should be a circle. Like that. Center is 0, 0, right? How do you know center is 0, 0? Because this will tell you that. So if this tells you center is 0, then when we see something like this, we understand z, center of z should be 0, 0. When it comes to here, now center is what? 2, 0, right? 2, 0 is somewhere here. 2, 0 is somewhere here. 2, 0. Now I'm going to make a circle there. So my radius is 1, right? So I have to stop from here. So this is going to be 1 here. Right? So this is my second diagram. So the understanding would be the radius from here to here is 1, and the radius from here to here is 1. So now in this situation, this z can be any point on the circle. In this situation, the z can be here, this z can be on the circle, like that, right? Okay, so now we'll do a question. Question would be, sketch, let's see, z minus 2 minus I mod is equal to 1 in an Argand diagram. In an Argand diagram. Okay, so now you don't have to solve it or simplify it, because you understand z minus 2 means in the real axis it goes 2 to the right. Yeah? So we can directly do this. We can directly do this. You go to the real axis by 2. Suppose you are here. Then y-axis 1 up here. So this is going to be 2. This is going to be 1. Right? So actually this coordinate would be 2, 1. Now this is going to be my new center. Center for this one. So, and the radius is 1. So it should be, radius is 1. So it should be something like this. Should be something like this. So this radius over here is going to be 1. Now, where is z now? Z is here, 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 and here, and here. Now, if you have just z mod is equal to 1, so that means it is here. What has happened? Z got translated. Z got translated to a new location. So when z got translated to a new location with the center, with a different center, so initially we had z's here, right? Once the transformation happened, the new z's are here. So actually, this means z can be on this circle with the new center here. Got it? Next one. Now we'll extend this idea in this way. Let z minus 2 mod is equal to z minus 2y mod. Right? So now we will think about this individually. Right? Think about this individually. So we understand z minus 2 means somewhere here, right? Somewhere here, 2. So I'm going to have a circle here. Right? I'm going to have a circle. Do I know? Now, very important question. I understand the point here, but do I know the radius? No. But in this question, radius is given to you, steady. So if you want to plot this one, you can plot this one in this way too. See? And you can have another one too. See? So what we are doing is, we are plotting this one. Why there are so many circles? Because the radius is not defined. So we have the flexibility to go as much as you want. All good? Next one. This is very simple. Next one, z minus 2y. So in that way you understand your center is going to be here. Z minus 2y. Now again, if you want to plot it, you can plot a lot of curves. You can plot a lot of curves. See? You can plot. See, you can plot a lot of curves. Yeah, this is not symmetric. The radiuses are not the same here. Now, what this tells you, this is nothing but the radius. This is nothing but the radius. So if you think about this circle over here, and suppose radius is some amount. If you think about this circle over here, and the radius is some amount, right? Radius is some amount. So what these are saying, what this is saying, this is a circle, this is a circle. These two circles are equal to each other. So if you look into it, those two circles are equal to each other here, see? You got it? And if you properly draw this one, if you extend this cut should be somewhere here. This is not properly drawn. This cut should be somewhere here. Yeah? So if this condition imposed to you, z minus 2 separately here, separately. If you think of this circle, it's here, right? Z minus 2y separately, if you think about here, individually, right? Individually, if you just think about individually this one. But when you equate that means z should obey this condition. So now I told you, where is the circle now? Okay, so yeah, these two here. So circle, suppose circle is like this. So at this point, you understand, at this point, this and this both are satisfied. At this point, also it is satisfied. At this point, also that is satisfied. So your z, which satisfies both, is on this line. Simple. Individually, they are on the thing, like this. Yeah? Or here. Or here. Yeah. So there is a common point here. See, this is a common point. This common point tells you this condition. And this common point tells you this condition. So likewise, there are a lot of common points tells you this condition. So if you connect those common points, that C is lying on that line. If you further extend this idea, extend this idea, so this is not to the scale, right? So what I will do, I will just take this line, okay? I will just take this line, right? Because if you extend it like this, all other intersections should be on this. If you draw it to the scale, okay? Now, my point is this. You understand, this is your z value, right? You understand this is your z value. What z value? This z value definitely satisfies this and that. Why? Because those circles are cutting. Now, What is this? That is z minus 2. What is this? That is z minus 2i. So this is z minus 2i mod. This is z minus 2 mod. That is what I was explaining. So we have to understand this circle thing is what is when we plot it. However, when you plot it, there are so many z values here like this, right? There are so many z values. So you pick one z value where this cut is happening. You take one z value, and then if you think about the distance from here to here and the distance from here to here, they are the same. That's what I was discussing yesterday. So that's what I said. You have to connect this logic, which I explained to you, with this circle thing, that understanding. So we get this point because those two circles are intersecting. Then the distance between these two are the same. Yeah? You get it? So this is what we discussed. If you summarize, this guy is a circle, this guy is a circle, and for that circle, this is the point we are discussing from this equality. There are three things here. First thing is this, second thing is this, third thing is this. So the first thing, this circle, second thing, this circle, third thing is the point. This is the third thing, this is the second thing, this is the first thing. Very logical. Now once you have that, this is the common point. Now the distance between these two is this distance. Distance is between these two is this. So these two are the same, right? So, and this, what is this line? This line is the path or the locus of z. Locus of z. Why? Because z can be on this line, so that when you connect to these 2 points, they are the same. Now, how do you get this point? How do you get this point? From a big circle and another big circle, right? But if you want to think in that line, I mean, we are wasting our time, but when I was teaching you, I showed it to you, this logic, because that's the right thing.